So the problem states that the tractor exerts a towing force T, 400 pounds force, and they want us to determine the normal reactions at each of the two front and two rear tires, and the tractor frictional force on each rear tire needed to pull the load forward at constant velocity. The tractor has a weight of 7,500 pound force and a center of gravity located at GT, given to us in the image. An additional weight of 600 pound force is added to its front, having a center of gravity of GA. Okay, take mu s equals 0.4, and the front wheels are free to roll. Okay. So we can neglect friction at the front wheels. So as always, let's start with our free body diagram. So at G sub T is where the 7,500 pound force is applied. We have a 600 pound force at G sub A. This is a side view, so even though we're seeing one wheel, we're actually accounting for two wheels on each side because the problem says two front and two rear wheels. But we'll show it from a side view. Excuse me. So with the normal force at the front wheel, we'll say N sub B, and we'll represent that the two, by two of those, equivalent. And with the normal force at the rear wheels, N sub C, once again, two of them. The front wheels, they said, were free to roll, so we can neglect friction there. The pulling force, T, is to the left. And that was given as 400 pound force. The height above the ground is given as 2.5 feet. We have to have the resisting or the contact surface frictional force, which is the opposite direction of the pushing or pulling force, as one for each rear wheel. So it's two of them. So we'll say 2 F sub S. And I think that's everything. All right. So if we start then with some of our forces in the X direction, you have 2 F sub S minus 400-pound force so if we take the moment about point C, then we can eliminate, this is point C, this is point B, given the problem. We can eliminate the normal force at C and solve for the normal force at point B. Let's go to a clean sheet.